Okay, the next example is finding the mean, standard deviation, and proportions of a distribution. So in the example, a density histogram of the ACT scores and points of seniors at Dana Hills High School is displayed in the figure below. Now, some of the bars have been left blank on purpose. So here's our density histogram. The area of each particular rectangle represents the proportion. And we don't know the last two. In order to find the last two, we know that this entire histogram should be equal to 1. So we're going to take 1 and subtract all the areas that we have. So we're going to subtract 0.14, 0.34, 0.34, 0.14, which means we get 1 minus 0.96, which leaves us remaining with 0.04, or 4%. Now, if you look at the left and the right part of this density histogram, they are both equal. So we're going to divide that by 2 to figure out what is the area or the proportion for those two, which becomes 0.02. So we can see here that that represents 0.02 now, that represents 0.02. Now, if you look at the middle number, this represents a bell-shaped curve, which is unimodal. Now, in the middle, we can see that the 20 could possibly represent the mean. And then what can we say about the increments? It's going from 5 to 10, 10 to 15, 15 to 20, so it's increasing by 5. So it's either above 5 points above or below the mean. So in the first example, part A, we want to find the proportion of the scores that are between 15 and 25 points. So if we take a look at 15 and the 25 points, so there's 15, there's 25. So we're looking at anything in between here, which is the proportion. We want to find the proportion, which is taking 0.34 plus 0.34, which gives us 0.68, or 68% of the scores are between 15 and 25. Next, what we want to do is we want to find the proportion of the scores that are between 10 and 30. So there's 10 and then there's 30. So that means we're going to go everything in between here. So we're going to add 0.14 plus 0.34 plus 0.34 plus 0.14, which gives us 0.96, and that is the proportion of the scores that are between 10 and 30. Next, we want to find the proportion of the scores that are between 5 and 35 points. So here's 5, so that's where it begins. 35 is where it ends. So we're going to include now the 0.02s in addition to all the proportions inside. So we have 0.02 plus 0.14 plus 0.34 plus 0.34 plus 0.14 plus 0.02, which gives us 1. Or if we want to convert that to a percent, 100% of the scores are between 5 and 35 points. Next, we still have our graph down here. We want to estimate what is the standard deviation. Well, if we know that 20 represents the sample mean, well, we can see that these are in increments of 5. So 25 minus 20 gives us 5. 20 minus 15 gives us 5. So we can say that the standard deviation is 5. Next, what we want to do is we want to estimate the percentile for the score 25 points. That means to the left of 25 points. So what we want to do is start at 25 and it's going towards the left. So we're going to add up all the scores that are 70, to the left of 25 points. So we have 0.02 plus 0.14 plus 0.34 plus 0.34, which gives us 0.84, which means that is the 84th percentile.